For today's lesson, our focus standard comes from Grade 7, Number Systems, Standard 1. Apply and extend previous understandings of subtraction to subtract integers. Our topic is from Adding and Subtracting Integers, Intro to Subtracting Integers. Our essential question is, what important reminders do we need as we begin to understand subtracting integers? Please take a moment, pausing the video if you need to copy the topic and essential question into your header along with today's date, set your question column and your note column, and resume the video when you're ready to begin. Adding and subtracting 0. Take a look at these problems here and write them down and give me the answer to each of these problems. So if we say 5 plus 0, so if we add 0 to 5, our answer is still 5. If we start with 5 and add a bunch of zeros, here I have 3, but we can imagine adding hundreds, what's our answer going to be? Well, adding nothing changes nothing, so our answer is still 5. If we start with 7 and subtract 0, our answer is still going to be 7. And if we start with 7 and subtract a whole bunch of zeros, our answer is still going to be 7. When we are working with adding and subtracting integers, particularly subtracting integers, we're going to have to be adding zeros on to be able to finish and complete the problem. And we want to remember that adding 0 to any value doesn't change the value. You can add as many zeros as you want, and it doesn't change the value that you started with. And that's an important concept to remember as we begin to understand subtracting integers. The next is the idea of double negatives. Now this looks a little more like a grammar problem, and it is, because the same rule in grammar applies in mathematics. What does this sentence actually tell me to do? Do not eat the ice cream. Well, I have a couple choices. I can not eat the ice cream, or I can eat it. But it's saying, do not do this. So not eat the ice cream would be this option. It does not want me to do that. So what's left is to actually eat the ice cream. Okay, let's take a look at another one. Do not brush your teeth. So again, it's saying do not do this. Well, the do this part is not brushing your teeth, and that's what it does not want me to do. So if it does not want me to not brush my teeth, it wants me to brush my teeth. When we use a double negative, it actually equals a positive. And so we're going to be looking at some subtraction problems where we see subtracting a negative, which is a double negative. And when we do a double negative, it's actually a positive. So we're going to see a little bit today how that plays out in subtracting integers. Now let's get to our example problems. So again, we're using subtracting integers examples, so we're starting to look at what happens in subtraction when we have positive and negative values. We're using the same key for the chips, and here's our first problem. We're starting with 5, and we want to subtract 3. Now that's a problem you already know how to do, but we still want to start there to identify how it's going to help us in more complicated problems. So it's telling us to start with 5 positives and take away 3. So we can illustrate that with our chips by saying, all right, well, I'm starting with 5, then I'm going to take away 3, 1, 2, 3, and what I'm left with is positive 2. So 5 minus 3 is 2. Let's try another one. For problem B, we're going to have 2 take away 6, or 2 subtract 6. Think about what that's going to be. Well, again, let's start with integer chips. So it's telling us that we have 2 positives, and we want to take away 6. Now, the problem here is I don't have 6 to take away. So we have to remember that we can add zeros, any amount of zeros that we need to, and it's not going to change what we're starting with. So let's add on 0 pairs to these 2 positive chips so that we can still say that we have 2, but that we have enough to take away positives. Here's what I mean. So here I've added 1 0 pair. So now I still have a value of 2 because a positive and negative is 0, but there's more chips available. We still don't have enough to take away 6, so let's add some more 0 pairs. Alright, so now we still have a value of 2 because these would all cancel out and leave us just with 2 positive chips. But now we have enough chips on our board that we can take 6 positives away. So let's go ahead and try that. I can take away 1, 2, 3, 4. Again, I'm just taking away the positives because this is a positive 6, 5, 6. So I started with 2. I added 4 sets of 0 pairs so I'd have more chips on my board. I can now take away from my board 6 positives, and what I'm left with is a negative 4. So 2 subtract 6 is negative 4. For problem C, we have 7 subtract a negative 5. Here's where we're starting to see that double negative I referred to earlier. Now it's in a math sentence. And earlier we learned that a double negative is actually telling us it's a positive. So let's see how that plays out with our integer chips. The problem tells us to start with 7 positive chips. So here we have 7 positive chips. And to take away a negative 5. But I don't have a negative 5 to take away. So just like with problem B, I have to add on some 0 pairs to be able to do that. And in fact, I need to add 5 0 pairs so that I have this 5 to deal with. So let's go ahead and do that. Alright, if you haven't drawn in your 5 0 pairs, please go ahead and do so now, and it should look like this. So on our board, we still have a value of 7, because we have these 7 positive chips, and we have the 5 0 pairs, which technically cancel out, so our value is 7. But now we're ready to take away the 5 negatives. So let's go ahead and cross those out. We would take away only the negatives, because that's what our problem tells us to do, and to take away 5 of them. 1, 2, 3, 4, 5. So how many chips are we left with, and what's their value? Well, we're left with these 7 plus 5 more positive chips. So 7 subtract a negative 5 is actually positive 12. Let's try one last problem. Negative 4 subtract 2. So this time we're going to start with negative 4 chips on our board, and we're going to take away 2 positives. Once again, we have the problem where we don't have 2 positives to take away, so we need to add on our 0 pairs. Pause the video here and add on your 0 pairs. See if you can complete the problem, then resume the video when you're ready to check your work with mine. Let's see how you did. So we saw the value of negative 4, although we've added on 2 0 pairs. And now we're ready, because we have enough chips on our board, to take away the 2 positives. If we take away 2 positives, 1, 2, we are left with a negative 6 chips on our board. So negative 4 subtract 2 positives equals negative 6. So that's going to conclude our video today as our introduction to subtracting integers. Remember, the 2 important reminders were that we can add or subtract 0 to any value and it won't change its value. This allows us to add 0 paired chips to our board in order to complete the subtraction problems. We also learned that a double negative actually equals a positive. So come ready to do more work like these problems in class.